Recently, I had the opportunity to try out a power station designed for the worksite. It had plenty of wattage and amp output. Here we're cutting down a tree with an electric chainsaw. Its obvious shortcoming is it was meant for the worksite and not for the home. Thus, when we tried running a refrigerator with it, we found that the inverter was unstable. Coming up on 48 minutes. Much to my disappointment, voltage is oscillating wildly, as is amperage. It also lacked convenient output ports, only having two 120 volt outlets. In today's video, thanks to the Home Depot Seeds program, we're looking at the Vector, the Freedom of Power 733 watt lithium power station. It has an output of 500 AC power, 10 watts on wireless, 15 on USB-A, 78 on USB-C, 120 watts on the 12 volt DC side, and it has a 10 watt LED light. Let's open the box and take a look inside. Lifting the multi-lid cover, we have an instruction manual, a box which contains AC power cord, a USB-C cord that can be used to charge the unit or run the device, and then this box which contains the power brick. Unfortunately, they didn't build this into the unit. Your AC cable connects here, then this plugs into the device for charging. We lift out the packing material, and via the handle we can actually lift out the unit. Weighs about 14.5 pounds. A look at the front panel reveals two places that are covered for your 110 outlet. Then you have a place to plug in a 12 volt adapter. There's also another place here for DC output, and that is up to 10 amps. Then you can go USB-C output of 18 watts or PD of 60 watts. And PD, that's for power distribution. It's just higher wattage and amperage for your USB device. Then, of course, there's the old-fashioned USB-A, and that's up to 3.1 amps. Then over here is where you would plug in to charge this unit, and that could either be off the included brick, or if you have a solar panel, you could also make a connection there. And by the way, you can run any or all of these simultaneously. The only limiting factor is the maximum output of the unit. Almost forgot, on top, there's a wireless charging pad. Above the electrical ports, we have the display panel, which is touch activated. You have power, the ability to turn on the charging pad, a rear light, DC power, USB power, and AC power. And again, you can turn any one or all of those on simultaneously. The display also shows you output power in watts and time remaining to empty, and a percentage of how much power is left in the batteries. The unit will auto shut off when no power is being drawn. On the back of the unit is a quick reference guide and a 665 lumen light that can also be dimmed and flash an SOS message. Each end of the unit has two power vents. Plugging into an external power source gives you an instant real-time display of the wattage coming in, the amount of time left to charge, and charging status. During charging, there is no fan noise. While charging, the unit can be operated and all its functions enabled, although not recommended by the manufacturer. At times, the controls on the front panel were rather unresponsive to touch. And at other times, they were just fine. When the unit finishes charging, the display will go off and the unit will shut down. With the charger still plugged in, even though we've plugged in a lamp and a phone, nothing happens because we have not energized the unit. So we turn on the unit, then we select what port we want to energize. So let's do the AC for the lamp, and our lamp comes on. Then let's select our USB for the phone, and that starts to charge. We can see the little battery indication there. And if we look over at our display, we can see that we have time to empty, 96.1 hours, and we're pushing 6 watts, and our battery is fully charged. The display also shows you what's being utilized, the AC port and the USB port. Did you notice how the time to empty dropped from 96.1 to 61.1? That time to empty will change as you change the load on the system. For example, if we turn off the light, we see that it's going to change from 61.1 to 67.2 as time to empty. To perform wireless charging, simply place the device over the center of this marking, and then you turn on the panel, and then a light will come on indicating that the unit is operating, and then your device should acknowledge that it is getting power. Another thing to note is that should one of these devices that's plugged in fault out, only that device will auto shut off. Let's say the phone malfunctions, right? And you get a warning, it'll shut down the charging to the phone, but it will leave your USB on and the AC on, so it auto isolates to the individual device that's causing a problem, which is really nice because you don't have to turn everything off. Another way of charging the power station is to use the sun. This is a 100-watt solar panel. We have the cable, which is not included with the power station. We plug in, and it looks like we're getting 51 watts of solar energy. The unit is at 95%, so it'll take about 37 minutes before it's topped off. And as you would expect, once the unit is fully charged, it cycles off. The third way to charge this unit is via the USB-C cable that's provided. Simply plug it into the PD port, then at the opposite end, plug it into something that can supply power. In this case, we're using this receptacle. Unfortunately, it only provides a USB-A connection, so I needed to attach an adapter to the provided cable. Once the adapter is in place, the receptacle provides 11 to 10 watts of charging. To give this power station a real-world workout, we're going to let it power this Samsung refrigerator. It uses 280 watts, 5 amps, and we're going to try to monitor the voltage and current use while it's running. Our setup is simple. We have the battery supplying power to the refrigerator, and we're tapping off a split here so we can get current draw, and then we're going into the other receptacle to get voltage output, and we're running a clock. Here we have voltage output of 114, and that's a sine wave output, and then amperage is just under an amp, half amp. When we come back here, we see we're drawing 38 watts, and we're fully charged. We're about a minute or so into this test, so we'll continue monitoring voltage to see how stable it is As we come up on 30 minutes, we see that we are at 92%. The fan is running on the unit. We're drawing 139 watts. We have 3.7 hours left to empty. And our current draw is just over 2 amps, so the compressor is running at fairly heavy cycle at this moment. Hertz is stable, 60.2. We come over to our voltage, also consistent at 113. As we come up on 1 hour of runtime, we are at 82%. The fan is now operating. We are running at 103 watts of output. Estimated time to empty 4.6 hours. Our current draw is 1.6, 60 hertz on the nose. Our voltage is back to 113. This inverter is doing an outstanding job with this refrigerator at this point. If we extrapolate at 82%, 1 hour in, it looks like we have maybe upwards of 8 hours of runtime, which is more than sufficient for the average blackout time that we have in this area, which is generally just a few hours. We are 3 hours into the test. The unit has outlasted my cell phone timer, which has already died. Our current status is 56% of battery level left, outputting 64 watts at the moment, and we have a time remaining to empty of 5.1 hours. If we come down to our meters, we still are at 60 hertz. Amperage being utilized is 0.9, and our voltage is 114. Again, the voltage and amperage are quite stable. Hats off to Vector for having a very stable inverter for this unit. With over 7 hours on the clock, we're just at 14%, and time to empty is 65 minutes. Frequency is still at 60. We're using 1.1 amp, and voltage is nice and stable at 114. I'm going to put an end to the test just because it's run 7 hours, and yeah, I could probably get another hour, but what's the point? This unit can actually run this huge refrigerator without any issues, and so should we have a power outage that endures that long, ours typically lasts no more than 1 to 3 hours when they do occur. This is certainly a device that we will have standing by. One of the claims is that this unit can run a blender. Well, I don't think so. This is rated at 550 watts. This has a 500 watt limit on it. We turn on the AC. Now we'll see if it blends. Nope. We get the warning light and the AC has shut off. 550 watts was just a little bit too much demand for this unit. While I might not be able to make a smoothie using this to power a blender, I certainly can get a lot of work done. Here we are running a laptop and a desktop computer with no problem. So we finally have resolved the mystery of the different watt numbers on the front of the box. 666 watt hours is the capacity of the battery. 500 watts is the maximum output of the AC ports. 733 watts is 500, 10 watts, 15 watts, 78 watts, 120 watts, and 10 watts all added up together, because this unit will actually allow you to run all these devices at once. And as long as you don't exceed 733 watts, the unit will operate. After several days of using this unit, I'm quite impressed with what the Vector can do. It has multiple ways of recharging it, and it has multiple ways of outputting AC and DC power to numerous devices. The fans only run when under a heavy load, and even then they're quiet. The front display keeps you informed as to the status of the unit, as well as providing touch control for all the ports. About the only negative thing I can say about this unit is the touch control panel, which can at times be problematic and other times is absolutely fine. There is, of course, the issue of the power brick. I wish that had been just built into the unit. But other than that, I think the Vector would be a great asset in any home. If you found this video interesting or useful, give us a thumbs up, leave us a comment, join the subscription team, and as always, thank you ever so much for watching.